Hey, Nikki. I wanted to get together with you because I was messing around with the new Tanzu platform, and I was really interested in how they have tied together the Cloud Foundry platform that's been around for 10 years that you've been helping people get up and productive on all this time, and then aligned that with a new Kubernetes offering.
Absolutely. Like you said, Cloud Foundry been around since 2011, right? People love it. They love the simplicity of it. And with Tanzu Platform now showing both runtimes, it's going to be interesting to see how this compares, right? So what does the K8's offering look like to kind of the muscle memory that people have already got with Cloud Foundry today?
Why don't we just go ahead and jump on in? I'm a developer. I know
Mhm.
nothing about Cloud Foundry or Bosch or vSphere, and I've just got source code and I got an application that I want to get running on the platform. I want to get deployed and get started on that path to production. How do I get started here, Nikki?
So when you start working on Cloud Foundry, the very first thing you're going to do is you're going to log on to Cloud Foundry. So, CF login. Yep. And here, it depends on what your foundation looks like. This is SSO, so this, we're using single sign-on here. But there's also the possibility you can log on to a foundation with just a user coded password. But Cloud Foundry is going to give you that SSO code that you paste in, and that's going to get you logged in to the foundation itself. What does that look like on the Kubernetes runtime side?
So I think it's pretty similar. Developer logs into kind of the central environment that's managed here. And so the developer can go ahead and do a Tanzu login. And that is done through a cloud service provider account.
Okay. Well, so far I'm liking it because, yeah, those commands are very similar. So it's muscle memory could be a thing here. All right. Well, the next thing a developer is going to do is they're going to get into their org and space. Now, these concepts are org is a high level construct that is kind of an organization construct. So you'll see most companies, they'll take an org, will be an application team. Now, once they get into the org, there's also going to be a space, and that space is another construct to use to organize code. These are isolated from each other, right? So you can't necessarily, it kind of blocks, you can't crosstalk between spaces, you can't crosstalk between orgs unless you explicitly state so. So you would do exactly what you're showing right here, CF target, my org name, and the space that I want to get into, and that's going to bring you into the proper space within Cloud Foundry.
Okay, well, that makes a lot of sense. And over on the Kubernetes side, they use very similar levels of organization. Instead of an org, they use a project level. That's kind of the top level of hierarchy. And then within the project, they have the concept of spaces, which is very similar. So for me, I say I'm going to use the Amber West project here, and then I'm going to go ahead and use my own space here, the Corby space. And now this provides a context on where I'm going to be able to deploy my apps.
Okay. So a little bit different in command line, but not so far, Tanzu project is org, Tanzu space, that's the same as the space for us. So there's not a lot of difference there. That seems, fairly easy to figure out. Okay. Well, so on the Kubernetes or on the Cloud Foundry side, sorry, the next thing they're going to do is, you're going to be in your Git repo. And in order to deploy an application into Cloud Foundry, you need to have a manifest. So the manifest is going to show and be declarative of what we want that application to look like. So if you could bring up the manifest for this app. So you'll see here applications. The name of this is going to be Spring Sensors. I'm giving 1 gig of memory to it. I want one instance running. The path shows where my code is that I'm going to deploy. And then, we could talk about build packs. It tells what build pack we're going to use. There's a couple different ways that this could be done in Cloud Foundry, but with this one, we do have the Java build pack offline, explicitly stated, and then any environment variables that you want. So a good example of this is, within a build pack, you can have multiple different JDKs. You can have, Java 8, 11, 17, 21. Your environment variable that we see here is we're going to use Java 17 for this. So this is going to tell the build pack which JDK that I want to use. What does this look like on the K8 side?
Well, I like it on both platforms because in both cases, we're bringing just pure source code, the same source code we would use to run on our local desktop. without having to know about whether it's landing on Cloud Foundry or Kubernetes. And I should actually kind of specifically point out we're in the same directory on both sides of these windows. We're deploying the exact same source code. So in your case, you had that Cloud Foundry manifest to say how to interact with the Cloud Foundry platform. And on the Kubernetes side, we have this concept of a container app and then also a build config. And these two files together provide that interface to describe how the app is going to end up being deployed on the platform. So I wish we had just one file like you instead of two over here, but I think the overall amount of platform-specific configuration is very low. We're not doing Bosch manifest or Kubernetes resources and stuff like that. So let's get to the magic part.
Yep. So with this one, with the manifest in there, you're just going to do a CF push. And if you have a manifest file in there, it will pick up everything with that manifest and it will deploy it just as it sets. So by default, it will look for manifest.yaml. But in your case, you called out Cloud Foundry manifest.yaml. And that's why we put the -f in there to specifically go to that manifest. This is where you could have different manifests for different environments within the same repository and deploy those.
And since this is a longer running process, I'm going to go ahead and kick off the parallel process on the Kubernetes and let you continue here. We'll get back to it. Go ahead.
Yep. So, on the Cloud Foundry side, you see that it's going through, it's downloading the build packs, and the build packs are just a collection of resources that are needed for that container to run. So it downloads that pack, it downloads the source code, and as it goes through, we're starting to see now that it's building the container. So on Cloud Foundry, we use Garden containers, not Kubernetes containers, but we're building the container, and we call that a droplet. So we're building that container, getting it built and ready to deploy. Once this is done, which we'll see here in just a second after the build is completed, it's going to automatically take that container and it's going to push it up to the platform. And it's going to do some looking to say, hey, how many application instances am I wanting to run? How many availability zones do I have? And it's going to find the best place to do that for high availability. So if you've got 3 availability zones and you've already got an instance of this app running in one, it's not going to put it in the same availability zone. It's going to move it over to another availability zone. It's going to look at things like where the Diego is, less loaded, where it has less tax, and, try to put the best place for it. And it looks like you're doing the same thing on the Kubernetes side. The build looks very similar, just with a little extra detail to it.
Well, we are using the build pack model. So you did a CF push, I did a Tanzu deploy, and I absolutely love the build packs because as a developer, this means I don't have to author the Docker files. I don't have to own the responsibility of going forward of doing security patches in the operating system layer or heat memory optimization for optimal performance or securing the container and stuff like that. It's handled for me, and I can just focus purely on the source code. The end result is mostly the same, that you and I have both deployed these apps without having to know much about the underlying cloud platform, and these are now runnable and reachable. Let's go take a look over. I'm going to look over at the web UI for your Cloud Foundry environment, and I can see in my development space here, my Spring Sensors application is running, and I can now hit it over the internet. I have HTTP access, and I can start hitting the web app here. I'll note, Nicky, that I am currently running with an embedded in-memory database. That's this HSQL DB. We'll come back to that in a minute. But if I go over to the Tanzu platform for Kubernetes, I have the same concept of spaces here. I can pull up my space. I can see the application that's running, and then I can hit the URL for my application. So this is the same source code, the same application. And now it's running, it's just running on a Kubernetes environment instead of a Cloud Foundry runtime here.
That's super interesting. But you know what, Corby? I don't like in-memory databases. If my app restarts, all my information goes away. I've got to start new. I want to put this on a MySQL database. So from a Cloud Foundry perspective, the way we would do this is we would create the service, CF create service. But how do we know what services are out there? There's a concept of a marketplace. So, if you do a CF marketplace, that's going to list all the services that you see there. And this is what we've got, this is what we're looking at right now. Do y'all have a marketplace on the Kubernetes side?
We do. And so I can go ahead and view that here.
Service
Uh,
type list. Okay.
yes, absolutely. So these are services that my platform engineer has made available to me for on-demand creation.
All right. So we know what service we want to do. So the way that we're going to do this is we're going to do a CF create service, and we're going to give it the names of what the service is that we want to create. Now, I
All
think,
right.
I was going
Yeah,
to
so
say,
the Cloud Foundry services are very robust stateful services that actually provision dedicated VMs
yep.
to host them, which mean that they are really awesome and can be used for production purposes as well. But it also means they take a long time to stand up. So I went ahead and created the service before we started this.
Okay. Yeah, that's what I was going to say. With those different plans, the fact that we are provisioning a separate VM for these plans and everything that goes into them, it can take a long time. I kind of figured that you pre-provisioned this out there, but let's define long time. Long time could be 5 minutes. It could be 50 minutes, depending on, what kind of service you're creating and, what the instance is of that type of service, right? A 50 gig is probably going to take longer than a 5 gig, so on and so forth.
Yeah, and for the record, this one was under 5 minutes. So
Okay. So once we can look at our services. So a CF services is going to tell you every service that's running it. And we can see that there's a sensor DB there. How do you see your services on the Kubernetes side?
over here, I do it. And so our services are done through Helm charts, which means that services are really going to be better suited for development use in order to spin up services that you may need for, a week or so in your environment.
Well, and I'm still seeing a lot of, consistency here, right? We're still seeing a lot of the same information. We do on the Cloud Foundry side, we do have like the plan attribute, which is something that's not really there on the Kubernetes side based on what you said on the Helm. We can see, upgrades available. We see a lot of that same information. So, service list versus CF service, there's not a whole lot of, our Tanzu CF service versus Tanzu service list. Again, very comparable commands, shouldn't be hard to, flip between the two, and you get a lot of the same information back from the service. So, okay, so we see our service offering there. Now, if we want to add, bind our application to it, we're going to do a CF bind service. We're going to tell it the application name and what the service is that we want to bind to. And it's just that simple. So what you're seeing right now is that the platform is going through, it's provisioning the secrets that are needed to connect to that database. It's putting those into the application and connecting those up. So we're seeing that bind service now. We're ready to do. Now, the one thing that you do need to take note of here is when you bind service within Cloud Foundry, that's introducing new environment variables, those secrets. So we do have to do a restart of this service in order for the bind to take place.
All right, cool. And I love this as an app dev because now what it is it's going to inject the database credentials into my application, and it's very portable across different environments. So I can connect to the staging database in my staging environment, production database in a production environment without having to update my code.
Yep.
We definitely stole that concept here on the Tanzu platform for Kubernetes. So we have this concept of taking the service binding we're going to bind the MySQL database to the deployed container app. And then one modern convenience with Kubernetes is that it's going to immediately reconcile and figure out it needs to trigger the restart of the container. And so I don't have to manually restart it. And it is now injecting these variables into my application.
So I'm looking at your service bind command here on the Kubernetes side, and it's very, very comparable to what we see on Cloud Foundry. What is this --AS?
That's just simply providing an arbitrary label, a name for the binding.
Okay, so that's a lot like what we do on the Cloud Foundry side when we say, hey, here's our application, here's our service, and here's our service name. That alias is doing basically the same thing. It's giving it a human readable service name so that you can immediately identify maybe who it belongs to, who started it, what it connects to. Okay, so that's extremely comparable to what we're seeing on the Cloud Foundry side. I do think, what I'm seeing here is there is a lot of muscle memory that seems to translate between Cloud Foundry and, the Kubernetes side of the platform.
All right. Well, I think we might have usable database services now. The bindings have completed. So let's go ahead and run back to our service. This is the Spring Sensors application on Cloud Foundry. You can see it's referencing the in-memory database. I'm going to go ahead and do a refresh on the app here and load it. And we can see now it is connecting to the provisioned VM MySQL on the Cloud Foundry environment. So any data that I generate now is going to get persisted into the MySQL database, which is fantastic.
Yep.
And if I run over to the Kubernetes equivalent, I can do the same thing. I'll go ahead and do a refresh on here, and I can see I'm now connected to the MySQL database that was provisioned in the Helm chart in here, and I can immediately begin reading and writing. So, I mean, that's a super accelerator as a dev to that quickly be able to spin up a database service, a messaging queue, a key value store, whatever it is that you need, and immediately begin testing your code against it.
Now hold on, Corby. So when you bound to this service, on the Cloud Foundry side, there was a restart in order for this to happen. I didn't see you do a restart on the Tanzu side.
Yeah, that's right. That was an advantage of the Kubernetes, is that it's a little bit more clever about reconciling when I say, hey, there's been a change in state. I got to restart the underlying container to reconcile. And so that was just an extra step I didn't have to perform there.
Okay, I like that. That's enviable. Well, I think Cloud Foundry is going to have to take that one on the chin because, yeah, you do need to restart your service on the Cloud Foundry side to recognize those changes in environment variables. That's awesome. So again, very comparable between the two.
That's great, Nikki. Well, thanks a lot. I appreciate you taking me through this, but I'm real happy that basically people can get a choice between whether they want to deploy on Cloud Foundry and Kubernetes, and the experiences seem to be pretty aligned. It feels like you can pretty comfortably move between these two platforms in terms of application delivery.
Yeah, I absolutely agree. I mean, Cloud Foundry has been a platform that's been loved by a lot of companies for a long time. Kubernetes is coming up. People are very interested in Kubernetes, but I don't think a lot of people wanted to lose the simplicity, that easy button that was Cloud Foundry. And it looks like the Kubernetes side of Tanzu Platform is bringing that in without having to change a lot of muscle memory that people may have already developed with Cloud Foundry. I think this is great. I'm excited to see what happens with this product.
Thanks, Nikki.
All right. Thank you, Corby. Appreciate it.